All right, today we're going to peel back the skin of the modern skyscraper. We're going to reveal a piece of engineering magic that you've absolutely seen a million times, but maybe never really noticed: the curtain wall system.
I mean, have you ever stood at the bottom of one of those giant glass towers, looked all the way up, and just wondered, how? How does all that glass, thousands of panes of it, just hang there? It looks so sleek, so delicate, yet it defines our cities. Well, it's not magic. It's just some seriously brilliant engineering, and that's exactly what we're about to get into.
So here's the game plan for this explainer. First, we'll talk about how our cities got that iconic glass skin in the first place. Then we'll dive into what a curtain wall actually is. After that, we'll look at how they work, weigh the good against the bad, and finally, we'll take a peek into the super cool future of building facades.
Okay, so picture a modern city in your mind. What do you see? I'm betting it's gleaming towers of glass and steel, right? That whole sleek, almost futuristic vibe, that look of progress. Well, it's not just an architect's whim. It's all made possible by the very tech we're talking about today.
I mean, think about the big ones. The tallest building in the world, the Burj Khalifa, just slicing into the sky. Or the powerful One World Trade Center, reflecting all of New York. Even that incredible spaceship that is Apple Park. The one thing they all have in common: that stunning, seamless skin of glass. And the secret sauce behind it all is the curtain wall.
So let's get right to it. Time for the big reveal. What exactly is this system that holds up the very face of our modern cities?
Okay, here's the secret. The single most important thing to understand is that a curtain wall is non-load bearing. That means it doesn't hold up anything. Not the floors, not the roof, nothing. It literally just hangs off the building's main frame, kind of like a curtain hangs from a curtain rod. Its only jobs are to hold up its own weight and, keep the wind and rain out.
This is honestly the best way to picture it. The building's real muscle, its strength, comes from that internal skeleton of steel or concrete. The curtain wall? That's just the high-performance skin. It's the sleek, high-tech raincoat that protects everything and everyone inside.
And when you put it side by side with an old-school wall, the difference is just night and day. On one hand, you've got a traditional brick wall. It's heavy, it's part of the structure, and it's built slowly, one piece at a time. But the curtain wall is the total opposite. It's incredibly lightweight, it's installed super fast, and bam, it floods the inside of the building with natural light. All right, so now that we know what it is, let's get into the mechanics of it. How do these giant glass and metal puzzles actually get put together on a skyscraper? At its core, every curtain wall is basically a big grid. The main vertical frames are called Mullions, and the horizontal ones are called Transoms. They create the openings for the glass you see through, and also for something called spandrel panels. Those are the opaque bits that cleverly hide the building's floors and columns. Then the whole grid gets bolted onto the building skeleton with these heavy-duty anchors and sealed up tight with gaskets to make it weatherproof. And there are two main ways to assemble this grid. The first is called the stick system, and it's kind of like building with individual Lego pieces right there on site, one mullion, one panel at a time. The other method is the unitized system, which is more like snapping on huge pre-built Lego sections. Massive panels, sometimes a whole floor high, are made in factory, shipped to the site, and just craned into place. It's a lot faster, and the quality control is often better too. But of course, no single technology is the perfect solution for everything. So let's get a balanced picture and really weigh the pros and cons to see why these systems are so popular, but also understand some of the challenges that come with them. So why do architects go for them so often? Well, this chart really tells the story. A huge 40% is just for the look, that sleek, modern aesthetic. But look what's right behind it. Speed of construction at 30%. In the world of multi-million or billion-dollar projects, time is absolutely money. Then you've got the benefits of natural light and having a lighter structure rounding things out. So here's the trade-off. On one side, you get that incredible look, fast construction, and more rentable floor space because the walls are thin. But on the other side, the initial cost can be high, and you need really skilled workers to install it right. Plus, maintenance, window washing a skyscraper is a whole industry, and all that glass can cause a lot of heat gain, basically turning offices into greenhouses if you don't use high-performance materials. Okay, so we've covered the what, the how, and the why. But where is all this technology headed? What does the future of a building's skin even look like? And this is where it gets really, really exciting. We're talking about smart glass that can tint itself on command to block the sun. We're seeing something called BIPV. That stands for Building Integrated Photovoltaics, where the facade itself becomes a giant solar panel. And we're even starting to see AI-designed systems that are perfectly optimized for a building's specific location and climate. It's wild stuff.
This quote just nails it, doesn't it? The buildings of tomorrow won't just house us. They will power, protect, and adapt with us. It's a total shift in thinking. The facade is going from being just a passive barrier to an active, responsive system. It's becoming a dynamic part of the whole building ecosystem.
And that kind of leaves us with this final big idea to chew on. If a building's entire skin can generate its own power and an AI can manage its energy use perfectly, what does that mean for our cities? The humble curtain wall, which started as just a way to make a building look glassy, could become a key player in the smart, sustainable cities of the future. Something to think about. Thanks for watching.